do a teamwork. The basic idea is, as long as you knows when you lose the information, when you gain the information, you can manipulate from how you select the data, how you sample in the data. Now, give an example. If I have this imbalanced data, let's say we want to find the communication of tourists, what is their characteristics, and you don't have a lot of data, but because it's so important, you can duplicate those data, make it more frequently, and then it can have more weight, right? That's one way to deal with the imbalanced data. You can manipulate, let's say, sometimes you find that we always misclassify something. And then this data is so critical, you can duplicate more and give it more chance to be learned. And just like the teacher, if I find a student that keep making mistake in that kind of problem, I'll just give more examples for that. Right? Make sense? The same way. And you can here to make a whole set of classify. The first one, how do you sample in the data? That's step one. You can do all these skills in statistics. For example, you can select the data with placement or without a placement. That'll make a whole difference too. In the step two, you can get multiple classifiers. You can get, let's say, 20. And they're all a little bit different because they're fit in different data. They might even use different algorithm. And the one is a Bayesian, another one is a support vector machine, another one is nearest neighborhood. You can use different classifier and a different data set. And then, when in the end, you can start to vote to see the majority win. In that case, of course, you're going to have a better chance to get the right strategy or the classifier. In the same way, like our President Obama or Bush have those so-called cabinet and advisors, and they each represent a particular expertise and have some deep understanding in a particular field. And then you ensemble them, they might give you a better idea and help you to avoid some blind angle. Any classifier in the same way, they have strengths and weaknesses. And if you merge them, get the majority vote, that's a little better. And the last thing you can also manipulate is even the result of the classification. Sometimes you can, in the middle, if in reality is yes, but from your classification and the experience, you can suspect the data itself is collected wrong in the first place. And you can even manipulate this in the end, if that's the truth. So when we talk about this, we have a lot of things we can do. And I talk about why. It's pretty simple. Let's say each classifier only got 65% of precision, accuracy. And you're going to assemble 25 classifiers. And the 25, the majority will be 13, right? So what's the possibility you have 13 all got wrong? With everybody have 65% of chance, what's the possibility you got 13 all got wrong? Well, the keyword is independent. If they're truly independent, it's an independent thinker, come from independent data, that's a huge assumption. Your possibility to get it wrong is 6%. Much better than 35%, right? That's the whole idea. Satisfied? So we have a few best choice. Now people doing research and backing. That's one group of method. Backing mostly manipulate in the top, the data selection and the vote. Another one is stacking. That means iterative to do it. You can have a few layers of classifiers. And the third, boosting. we're going to focus on the boosting because that's the best. When I say the best, keep that in mind. Every method published the best in something. Just like the Olympic gymnastic competition, you could get one athlete that the champion of all around the total score. But they never win any champion in any single game. But you could get somebody at the best in the rain, the best in the bar, the best in something. And I would say to you, everything in this, what we learned, historically proven to be the best of something. But overall, so far, the ADA boost could be the all-around champion. So basically, you can combine multiple models, or sometimes even meta models, M-E-T-A. That means they come from different algorithms. And then you can construct from the same training set, from different training set, and put it together and to tune to pass the test. You can do a lot of things. Basically, you are trying to take advantage of the instability of the classifier. Just like sometimes we vote for somebody, even depends on a mood. So if we get more, the instability will be helper if we get many. That's how the democracy works, right? It can help avoid overfitting and compensate the poor learning algorithms. Basically, use all the strengths, but of course, the price you have to pay is more computation. It really depends on what data you're talking about. Like medical data, computation is not a problem. Compared to collected data, it's much cheaper, right? So, backing first.